My topic is harmful algal blooms. Harmful algal blooms don't just affect our oceans, they also form in bodies of fresh water, making lakes, ponds, or your favorite swimming hole smelly and slimy. Algal blooms are odious, but more important, they can also be dangerous, imperiling public health and aquatic ecosystems, and closely affecting local economies. What is an algal bloom? According to aquatic food web, algae are photosynthetic organisms. In other words, they derive energy for the growth from the sun. An algal bloom is the overgrowth of a microscopic algae or algae-like bacteria in fresh, salt, or brackish waters, depending on the type of algae or bacteria that cause it. An algal bloom may produce bad-smelling scum, foam, froth, or paint-like slick. Algal bloom can be many colors, including blue-green, yellow, brown, pink, and red. The most common type of freshwater harmful algal blooms, cyanobacteria. The color is blue-green algae. The cyanobacteria blooms are the most common type of hubs in lakes, ponds, and other freshwater systems in this country, although they can occur in brackish and saltwater environments. 2. Cyanobacteria are, as the name suggests, bacteria, but they perform photosynthesis like algae do and are often referred to as blue-green algae. Some, though not all, types of cyanobacteria can produce dangerous cyanotoxins. The most frequently reported type of the bloom-forming cyanobacteria is Microcystis. Golden algae. Although found mostly in oceans, golden algae, Primonium parvum, are an emerging problem in freshwater rivers, reservoirs, and lakes, particularly those with a higher salinity due to the higher mineral content, such as those found in Texas and New Mexico. While a bloom of golden algae can cause massive fish kills, it hasn't been shown to pose a health threat to humans. What causes freshwater algal blooms? There are two causes of freshwater algal blooms. Those are nutrient pollution, warm water. In nutrient pollution, nutrients like nitrogen and phosphorus essential to plant growth are a natural part of underwater ecosystems. But when they run off urban and rural surfaces and flow in a river, lake, and pond or reservoir in excess, a phenomenon known as nutrient pollution, they act like fertilizer and promote the growth of algae and bacteria. Most excess nutrients enter waterways via agricultural runoff, particularly from animal manure and chemical fertilizers that get washed from farms by rain. Leak waste from animal feedlots, storm water runoff from urban and suburban areas, and discharges from wastewater treatment facilities. Warm water gives cyanobacteria a competitive advantage. These bacteria grow faster than more benign algae in higher temperatures, and once a bloom forms, a feedback loop can be triggered. As blooms grow thicker, the dark surfaces of the algae mats absorb more sunlight, which leads to warmer water and more algae growth. Still water. Slow-moving or stagnant water can also become thermally stratified, meaning that a layer of water which favors algal blooms float on the top of cooler water. Factors that contribute to decreased water flow or funding include drought, water extraction for irrigation or drinking, and the alteration of natural waterways via dams, canals, and other man-made infrastructure. Climate change. Climate change, more severe droughts also modify the flow regime in freshwater bodies and can increase competition for ever scarcer freshwater supplies. Reduced flows in waterways means the remaining water will be warmer and more stagnant, creating conditions ripe for algal blooms. If we continue to look to natural waterways as our primary source of water, don't employ efficiency, conservation, and reuse measures to reduce excessive water diversions, freshwater bodies will become more vulnerable than they already are to hubs and the effects of climate change. What are the effects of freshwater harmful algal blooms? Health risks. People can be exposed to hub toxins by swallowing or swimming in affected waters, eating poisoned fish or shellfish. Even when food is cooked, algal toxins remain, or inhaling airborne droplets of affected water, depending on the level of exposure and the type of algal toxin. Health consequences may range from mild to severe to, in extreme cases, fatal. These are the three classes of cyanotoxins, and each type has different effects. Neurotoxins, which can cause neurological damage. Peptide hepatotoxins, which can cause serious damage to the liver and other. Dermatotoxins, which can cause skin irritations and respiratory issues. Imperial drinking water supplies. Boiling hot contaminated water not only doesn't destroy toxins but can in fact increase their concentration. Thankfully, drinking water treatment process can typically remove algal toxins, such as those from cyanobacteria, but if processing facilities aren't well maintained and up to date, the bacteria may remain in the water. Inadequate treatment can compromise water quality and threaten public health, and disrupt or even shut down treatment plants. Economic costs. Hubs cause lakes, reservoirs, and rivers to become unsightly and at times dangerous, reducing tourism, recreation, commercial fishing, and property values, and increasing water quality monitoring, management, and treatment costs. Even single bloom events can be crushing for local economies. Sick animals. The toxins released from a hub can cause large-scale fish kills, commonly seen as a result of golden algal blooms, and work their way up to the food web, impacting mammals, birds, and other wildlife that fed in grasses, shellfish, or fish tainted with toxins. Dead zones. Even non-toxic hubs can have a detrimental impact on aquatic ecosystems in the form of dead zones, areas in a water body with so little oxygen that aquatic life can survive. Also known as hypoxic zones. Dead zones are typically a result of eutrophication, which is what happens when a waterway becomes overly polluted with nutrients. When algae and bacteria in an algal bloom die, the decomposition process uses up most of the surrounding oxygen, causing other organisms in an affected water body to suffocate and die or be forced to relocate to survive. Increased turbidity. A bloom of algae on the water surface creates a turbid or cloudy underwater environment, one that prevents much of the sun's light from reaching bottom-dwelling organisms, including plants. Underwater plants are often a critical source of food and shelter for the other organisms, and without them, entire aquatic food webs and ecosystems can suffer. Preventing freshwater harmful algal blooms. Better farming practices. On farms, regenerative practices that improve soil health help to capture rain where it falls instead of allowing nutrient-packed runoff to wash into bodies of water. These practices include planting cover crops, diversifying what's grown, reducing tillage, properly applying compost and manure, and following fertilizer best practices. Green infrastructure. I mentioned above, it's not just farms that produce tainted runoff. Adding green roofs, planting trees, and building gardens of rain-absorbing plants all capture rain water before it flows into waterways. Smart water policies and conservation. Protecting wetlands, which act as natural filters to improve water quality, capture runoff, and enhance biodiversity, is also vital. Monitoring, mitigation, and collaboration. The state responded by creating a guide for addressing HABs, launching a public awareness campaign, and posting signs at lake, ponds, rivers, campgrounds, and fishing spots that, that ask for the public help in locating HABs. Unfortunately, too many states fail to even monitoring for HABs and alert the public of the risk, let alone to take significant steps to reduce outbreaks in the first place. Knowing where HABs are occurring and whether the government is responding is a critical first step to keeping our waterways, families, and ecosystems safe.